and good morning.
Waalaikumsalam. Morning, Miss.
Okay. Today class. Okay, actually, topik alternating current ni kita dah settle. Okay, dah habis dah sebenarnya. Saya kata macam ada lagi kan, sebenarnya dah tak ada. So tapi hari ni, okay, tapi hari ni saya akan tunjuk awak exercise lah. Okay, beberapa contoh exercise untuk topik alternating current, and then we move to our last topic. Actually today is our last class or our last lecture. Okay. Another topic, electromagnetic. Okay, that is the last topic. Okay, but before we proceed to electromagnetic, okay, we go through exercise for alternating current. Okay, you tengok dia punya example. Mana? Okay, I'll show you the example for alternating current exercise. Just a several example. Susah sikit hari ni sebab saya pun kena work from home. So, tak adalah apa tu, saya punya whiteboard dekat belakang. But it's okay. I just show you this example. Okay, saya dah buat dia punya solution dekat word ni. Okay, so for example 1, this is example 1. You can see here exercise 1. Okay, this is for exercise 1, RLC circuit. Okay, and this is the example for exercise 1. Okay, the question is, saya letak sebelah-sebelah. Awak boleh nampak tak ni? Ish. Okay, this is exercise 1. Okay, this is the your friends punya dia tengah masuk ni. Okay. Sekejap. Ni sekejap. Kenapa mesti hilang semua benda ni? Sekejap Okay, this one. Boleh nampak tak ni? Boleh kan? Okay, boleh nampak kan? Can you see this? Boleh tak? Okay. Okay, this is the question for exercise 1. Banyak your friend tengah masuk ni. Sekejap Okay, this is the solution. Okay, this is the solution. Okay, for exercise 1, this is RLC circuit where you have a resistor and inductor connected in series. Okay, so the first one is you need to find the current for the circuit. Okay, you need to find the value for the IT. where you have the value for the voltage here, VT, okay? And then draw a phasor diagram for the voltage and current. Okay, you have two questions. Find the current for IT and draw a phasor diagram. Okay, from this question, first step you need to convert this inductor into impedance, okay, into impedance, where you need to find the value for the ZL here, okay. So you need to convert this into ohms unit, okay. So 50 millihenry and 100 millihenry, okay, we need to convert it into um, ohms unit or into impedance, okay. So you have a value for the VT. um, you know that the VT is equal to this is the value for the V 50 square root 2, okay. So you need to divide by the square root 2, so you get the value for the V is 50 volt here, and this is in the polar form, okay. And then find the value for the ZT or the total impedance. So you need to add to sum of all the value for the impedance, for the for the resistance here, and for the inductance here. So, but first of all, you need to convert this inductance value into impedance value. So you know that ZL is equal to J omega L. So this is J omega L. J times omega, omega is equal to 6 to 8, okay, times L. Okay, L is equal to 50 millihenry and 100 millihenry. You can actually you can sum sum both of it. So or you can sum it first. It become a 150 millihenry, or you can do it like this. Buat dia asing-asing. Okay, selesaikan dia macam ni. Okay, or you can just write down J times omega 6 to X times L. L is equal to 150 milli. Okay, so and then you get the value for the total resistance here is a 57 plus J 94.2 ohms. Okay, and then you convert it into the polar form. Okay, after that you find the value for the I is equal to V over V divided by total impedance. Okay, so the value for V here is a 50, and the value for the total impedance here is a 110 58.82 degrees. Okay, so here is the value for the I or current, and then you need to find the value for the IT. So it means that you need to show the value for the I in time domains. Okay, so IT is equal to 0.4545 multiplied by the square root 2, cos you write down again the value for the omega, and this is the value for the degrees. Okay, okay, and then draw a phasor diagram for the voltage and current. So for the phasor diagram, um, you need to look into this polar form, okay, or in this phase form, okay. So this is for I 0.4545 and minus 58.82 degrees, and V is equal to 50 0 degrees. So 50 0 degrees is here, is a value for V, it's a 0 degrees, so it means that it's located in the x-axis. Okay, and then for the I, is a 0.4545 minus 56.82 degrees. So minus 58 minus 58.82 degrees minus 58.82 is here. Okay, is a minus 58.82, and this is the value for the I. Okay, and this is the phasor diagram for the B and I. Okay, so this is the answer for the exercise 1, and we look at the next exercise. Okay, this is exercise 2. I just show you for uh, just for the 3 example. I think the last one is the last question. Okay, um, so here is a exercise, next exercise, exercise 2. Okay, so the question, this is a series and parallel. You combine the series and parallel together. Okay, this is the series and parallel, series parallel circuit. Okay, so find the value for the current IB for the circuit. You need to find the value for this current. Okay, and draw a phasor diagram for voltage AB and current B. Okay, so you need to find the voltage for VAB, means that this is the node for A and B. So you need to find the voltage here. What is the voltage across 5 ohm? Okay. Sebelum tu, you boleh dengar clear tak suara saya? Ada sekat-sekat tak? Boleh. Sebab saya punya internet dekat rumah tak berapa bagus sangat sebenarnya. Okay. Um, okay, find the value for the IB. So you need to find the value for this current. So first of all, you need to find the total impedance ZT. Okay, so you find the value for the ZT here. ZT is equal to ZAB plus J5 ohm. Where is ZAB? ZAB is the impedance here, the total impedance here. Okay, ZAB is equal to the total impedance here. So here the impedance here is a 2 minus J2. Okay, impedance here is a 2 minus J2 ohms. So impedance here and the resistance here is a parallel. Okay, so you need to find the value for the total impedance here. Okay, so means that for ZAB, okay, for ZAB for impedance AB here, 5 ohms, okay, 5 ohms, this 5 ohms is a parallel with 2 minus J2, is a parallel with this one. This resistor is parallel to this. Okay. Okay, so 5 ohm is parallel to 2 minus J2 ohm. Okay. The impedance here is a 2 minus J2. So you need to combine these two first. Okay. 2 plus minus J2. Okay. You get the 2 minus J2 ohms. Okay. So this is the impedance for this part. Okay. And then for ZAB is equal to impedance here, the total impedance here, okay, is a 5 ohm parallel to this. Okay. So how to find the ZAB? ZAB is equal to 5 is a parallel sama ada you guna 1 over you can use a 1 over ZAB is equal to 1 over 5 plus 1 over 2 minus J2, or you can use this. Okay, 5 darab 2 tolak J2 bahagi 5 tambah 2 tolak J2. Sama je sebenarnya. Okay, use a you boleh guna parallel punya equation lah. Macam mana you buat apa nama, you buat a solution for the resistance. Okay, macam inilah juga you buat untuk this circuit. Sebenarnya the problem is how to find the hardest part for this topic actually is to find the value for the total impedance. Okay. Sebab dia kalau dia series tak apa, kalau dia series selari ni yang jadi masalah. Selari tu selalunya buat dia jadi masalah sikit lah. It's hard to find the value for that thing. Okay, so you find the value for the ZAB or impedance AB. It means that it's impedance here. So you get the value for ZAB is equal to 1.69 minus J 0.940 ohm. Okay, nanti boleh cubalah. So ZP is equal to, so the total impedance here is equal to J5 ohm plus this impedance. Okay, J5 ohm plus ZAB. So you get this total impedance is equal to 4.398 67.28 degrees ohm. Okay. Okay. You need to find the value for the IB. Okay. So if you want to find the value for this I, you need to find the value for the IT first. Okay, the total current. Okay, the total current is equal to this voltage 15 divided by the total impedance. So you get the value for the total current. Okay, and then after you get the value for the IT or total current, okay, you can find the value for the VAB. Okay, what is the value for the VAB? VAB is a voltage here. Okay, VAB is a voltage here. So VAB is equal to I total times multiply by the ZAB or impedance at this. Okay, so you get the value for the ZAB is 6 here is a 1.943, okay, minus 27.05 degrees. Okay, you multiply by the value for the IT, so you get the value for this voltage. So this is the value for voltage here. The value for voltage here is equal to the value for the voltage here. Okay, so if you combine this one, okay, and use the IT multiply by this ZAB, you get the value for the VAB. Okay, konsep dia sama je macam mana kita belajar sebelum ni. Okay, cuma bezanya adalah nombor. Okay, the presentation of the number you have in terms of the complex number and polar form lah. Okay. Okay, and then what is the value for this IB? Okay, you know the value for this V. Okay, so for IB is equal to VAB divided by this total impedance. Okay, so you get the value for the IB is equal to 2.34 minus 51.34 degrees. Okay, konsep dia sama je. Okay, and then draw a phasor diagram for the VAB and IB. Okay, so phasor diagram for the VAB and IB, so you need to look at the value for the VAB. Okay, VAB, dia tanya you phasor diagram. So once phasor diagram, you kena tengok this. Okay, in polar form, in phase form or polar form punya bentuk lah. Okay, you refer to this, and then IB you refer to this. So you need to draw this one and this one. Okay, so for VAB is 6.627 minus 96.34 degrees. Okay, dia agak-agak je 96.34 degrees ni dekat mana? Disebabkan dia negatif, so dia berada dekat bawah. Okay, and then 6.627, this one is 6.627, And then IB is 2.34. This is 2.34 minus 51.34 degrees. Dia punya sudut, okay, dengan dia punya value of this, you boleh agak-agak je lah, okay. If this is 6.6 and this is 2.3, so this is 6.6 and this is 2.3. So 6.6 mestilah lagi panjang betul value dia daripada 2.3. Janganlah tiba-tiba dia punya IB dia lagi panjang daripada dia punya VAB. Benda tu nampak tak logik lah. Okay. Lagi satu, this degree is a minus 96 and this is minus 51. So minus 96. Okay. Mestilah dekat sini betul. Dia lebih sikit pada 90 degrees. Okay. So, janganlah buat dia kurang daripada 90 degrees. Benda tu nampak tak logik kan. So dia minus 90 degrees, dia lebih sikit lah daripada 90 degrees, and then this is minus 51. Okay. And this is a phasor diagram for VAB and IB. Okay, this one is a exercise apa ni? Okay, this is for exercise 6. And then masuk lagi. Okay, this is for exercise 6. But the answer here is tak sama sangat dengan I punya jawapan. Saya rasa this answer dia salah sikit. Okay, okay, just look at this. Okay, this is also a combination of the series parallel. Okay, series parallel maksudnya ni adalah series kita series lari. Okay, okay, so you need to find the total impedance and sketch the impedance triangle. Okay, find the total impedance and sketch the impedance triangle. Okay, for this topic, what you need to know is if the question asks you to sketch or draw, you just have a two possible question. There is either it want to wants you to sketch the impedance triangle, or the question asks you to sketch the phasor diagram. Okay, so dia ada dua je, sama ada impedance triangle or phasor diagram. Okay, if impedance triangle ni dia suruh awak refer dia punya total impedance lah selalunya. Kalau phasor diagram ni is refer to the voltage or current in your circuit. Okay. Okay, total impedance. Okay, so the total impedance, you need to find the total impedance here, you need to find the total impedance here, and you need to find the total impedance here, and then these three impedance are connected parallel. Okay, so 1 over ZT, or 1 over the total impedance, is equal to 1 over 6 plus 12.5G plus 1 over 5 minus 9.95J, okay, plus 1 over 20. Okay, so last kali you put you punya solution semua ni. Okay, nanti saya akan bagi awak this apa nama solution ni dekat awak punya, dalam awak punya group WhatsApp. Okay, tapi ada 3 je lah saya cuba, yang lain awak cuba sendiri. Okay, so this ZT is equal to 8.1 minus J 1.015 or in polar form. This is the answer. Okay, and then find the value. You find the value for the IT. Okay, V over ZT. Okay, this is the value. And where is the value for the IA? Okay, actually this IA is equal to this voltage divided by this impedance. Okay, so you know that this is a parallel circuit, so means that the voltage here is equal to the voltage here, is equal to voltage here, is equal to voltage here. Okay, so disebabkan dia lintas selari. Okay, so dia punya voltage dia sama. Okay, okay, so this is the value for the IA. Okay, and then you find it, you sketch the impedance triangle. So impedance triangle, you need to refer to this ZT. Okay, this. Okay, okay. So this is 8.1. So the value for R is 8.1. Okay, and this is minus J 1.015. Minus J maksudnya dia dekat bawah lah. Minus J, okay, means that this circuit is capacitance. Okay, is a jenis capacitance. Okay, kita boleh jadi dua jenis, sama ada dia jadi capacitance or inductor. Okay, so here is a minus 1.01. So maksudnya dia dekat bawah lah. Okay, so this is the impedance triangle. Okay, the word triangle ni pun menunjukkan awak punya jawapan ni nanti awak need to show it dalam bentuk triangle macam ni. Okay, okay, so okay, this is Z 816, means that the value here is 8.16 and sudut here is the minus 7.14. This is impedance triangle. Okay, jangan confuse pula dengan phasor diagram. Phasor diagram bentuk dia macam ni. Okay, impedance triangle bentuk dia macam ni. Impedance triangle selalunya dia kena rujuk daripada nilai impedance lah. You need to refer the impedance value. Okay, okay, yeah, that's it. The amount of the current supplied to the circuit is IT and the current value for the IA is here. Okay, if katakan your question ada tanya what sketch the phase diagram for voltage and current. Okay, sketch the phasor diagram. Sketch the phasor diagram for the voltage and current. Okay, so you ambil lah dia punya current. Kalau dia tak nyatakan current apa, so you just refer to the total current and the total voltage. Okay, so here is your total voltage is 240 0 degrees and your total current is 29.177.14 degrees. So you need to draw this lah. Okay, this one and this one. Okay. Okay. Okay, ni je 3 je contoh yang saya tunjuk. Okay, you have a six exercise. Ni jawapan dia ada beza sikit daripada jawapan saya tadi. Saya rasa ni jawapan dia salah. Okay, this one saya dah check answer dia betul. This one saya tak check pun tapi saya rasa betul. Kalau you dapat jawapan yang salah nanti you bagi tahu I. Okay, and then this one pun saya tak tunjuk. I just show you this exercise and this exercise. Okay, okay, ada beberapa soalan tak pasal this topic? Actually kita dah settle this topic Ada beberapa soalan nak tanya? Actually your topic for the AU or alternating current ni, what you need to know is how to convert the value for the total resistance for the total impedance. Okay, how to convert from complex number to polar form, how to convert from the polar form to the complex number. Okay, how to selesaikan multiplication, how to selesaikan division, how to selesaikan add or subtract the polar form number and the complex number, okay, and then how to draw the how to draw the phasor form, how to draw the impedance triangle, benda tu je yang awak kena tahu in this topic, okay. But the problem is selalunya masalah tu adalah daripada how to find the value for the ZT, okay, the total impedance kalau dia melibatkan parallel case, okay. If you have a parallel case, the series parallel or parallel saja, okay, benda tu sebenarnya yang jadi masalah sikit. The rest sama je, okay. So if you dapat dia punya jawapan ZTU betul, okay, saya rasa you boleh dapat jawapan sampai end of the question tu, boleh dapat jawapan. Tapi kalau you punya Z total tu dah salah, okay, so you ada masalah lah dekat situ. So you know how to use a calculator, okay, you know how to use a calculator, you can check your answer with calculator first, okay. So actually we can use a calculator to check answer. Just if you have a value, you want to find a value for the ZT, 1 over ZT equal to 1 over A plus 1 over B, okay. Just insert the value in terms of whatsoever number you have, a complex number or a polar number. Calculator can give you the correct answer, okay. So use it to check your answer first, okay. Sebelum you proceed untuk cari dia punya nilai current, dia punya nilai voltage yang lain, okay. Ada apa soalan lagi sebelum kita move to next topic? Tak ada, okay. So this topic awak ada your final exam include this topic, ada satu soalan pasal arus ulang alik ni, okay. Okay. Okay, actually, okay, this is our last topic. Okay, this is our last topic and today is our last lecture class. Okay, about this topic, this topic is about the electromagnetism and there are no calculation in this topic. Okay, tak ada calculation. So today you dengar I cakap je lah. Okay, awak akan dengar apa yang saya bagi tahu je, saya cakap je. So it's dia tak ada calculation, dia semua is a theory, okay, it's just a theory. So actually if you read by your own you can understand, but we just go through this together, okay. So saya akan terangkan je secara simple lah, okay. Okay, actually this topic pun tak ada dalam your final exam, okay. This topic tak ada tanya dalam your final exam. So kita tengok apa yang ada dalam ni, okay. Actually magnetic ni is one of the basic topic in the electric actually. macam mana voltan atau arus terhasil pun sebenarnya ada unsur-unsur magnetik. Okay. Banyak slide ni, ada 100 lebih, tapi saya go through saya tak go on to detail lah. Saya terangkan secara ringkas. Okay. What is magnet? Okay. Sebab benda ni you boleh baca sendiri. Okay. So you boleh baca dan you boleh faham. Okay, hari ni kita go through lah sekejap sikit. What is magnet? Okay. It is a material or object that produce a magnetic field. Okay. What is the magnetic field? Magnetic flux and magnetic pole. Okay. Magnetic field exists around the magnet. It is a space field with a magnetic flux. Okay. Magnetic line or magnetic flux is a circle of magnetic force field lines, and magnetic pole is that area at the end of the magnet with a stronger external magnetic field. Okay. So if you have a magnet here, okay, you have a magnetic field around this magnet. Okay. Okay. So this line we call a flux. Okay. A circle of magnetic force field line. Okay. This is flux. Okay. And magnetic poles is here. Kutub. Okay. Bahasa Melayu kita panggil kutub. Kutub magnet. Okay. This is the area at the end of the magnet. So yang ni kita panggil north pole, and this is the south pole. So this is kutub utara, and this one is a kutub selatan. So the strongest magnetic field akan berada dekat kutub lah. Okay. There are two types of magnet. You have a permanent magnet and a temporary magnet. Okay. And this is the characteristic of the magnet. Okay. Magnet attract object made of the magnetic material. Okay. This is the example of the magnetic material. We have iron, nickel, cobalt, alloy, steel. Okay. So kalau magnet ni dia akan boleh attract objek yang ada magnetic material. Okay. Ini semua benda ni lah. Characteristic of the magnetic field line. The magnetic field line shows the exit direction from the north pole to the south. So dia akan direction dia, okay, adalah dari utara pergi ke selatan by forming a complete circle. Do not intersect with each other. Okay. And at the poles are the area near to the magnet, the flux is denser. Flux density is higher and the magnetic effect is stronger. So dekat hujung ni or the pole, at the pole of your magnetic is the effect of the magnetic flux density is higher. Maksudnya dekat sini kekuatan magnet tu lagi tinggi lah. Okay, dekat hujung dia. Okay, the magnetic field line in the same direction will attract each other, and magnetic field in opposite direction will repel each other. Yang ni saya rasa semua tahu kot. Okay. Magnet yang jenis yang sama akan tarik. Okay. Same direction will attract each other, opposite direction will repel each other. Okay. Ni contoh ni. This is the magnetic line for a bar magnet. Okay. Magnetic field line between unlike poles and the magnetic field line between the like poles. Okay. So kalau dia pole dia sama, dia dekatkan, dia akan tolak each other. Okay. Kalau pole dia lain, utara, selatan, it will attract each other. Okay. So it depends on this line lah, this flux. Okay. Awak nampak kan ni kan, yang ni daripada utara dia pergi ke selatan. Yang ni because of there are different pole, so dia akan tolak antara satu sama lain. Dia punya flux ni pun dia tak akan bersentuh. Okay. Okay, magnetic field line pattern. Okay, when current flows through a conductor, a magnetic field is produced around the conductor. The pattern of the magnetic field line depends on the shape of the conductor. The magnetic field line pattern is represented by the magnetic field line. The closer the magnetic field line indicate the higher the strength of the magnetic field form. Maksud ini. Okay. So compass in the magnetic field, the pattern and the direction of the magnetic field can be determined by a compass. Okay. So kalau you ada magnetic bar, actually we can see this flux here uh, dengan mata kasar. We cannot see, okay, this flux, okay, and the orientation of or the direction of this flux. So how to know is um, how to determine the direction is to put a compass at this area. Okay. So kalau you letak kompas, okay, arah kompas tu akan menunjukkan ke mana sebenarnya arah flux tu. Okay. The pointer of the compass is always in the direction of the magnetic field. So if you put a compass, so you boleh tahulah arah mana flux tu bergerak. So then you know uh, the magnetic pole dari arah mana utara, arah mana selatan. Where is the north? Where is the south pole? Okay. When a few compass are put near to the bar magnet, the pointer of the compass are all in the direction of the magnetic field. If a compass is placed near to the current carrying wire, the pointer of the path will point along the direction of the magnetic field generated by the current. This will discuss in electromagnetism. Okay, actually, if you have a one root bar or one wire that have a current, actually um, at the outside of the bar or the outside of the your wire, you have a magnetic field. Okay, nanti kita tengok contoh dia apa yang dimaksudkan. What will happen to the poles of the magnet when the magnet is cut in two? If you cut a magnet in pieces, each pieces will still be a magnet with the two poles. Ini maksudnya. If you have this one magnet bar and we cut it into two, okay, it will produce another magnetic bar with the two pole. Okay. What is electromagnetism? Bosan sikit topik ni. Okay. Selalu kita kira je kan. This is the only one topic yang kita tak kira. Okay. Adalah kiraan dia tapi sikit sangat. Last nanti saya tunjuk. What is electromagnetism? Okay, tindak balas yang berlaku apabila arus elektrik dialihkan pada konduktor yang menghasilkan medan magnet. Okay, this is okay, if you have a root bar or you have a one wire and you supply the current through this wire, okay, there are magnetic field outside this wire. Itu dia maksudkan magnetic field. Okay. The magnetic field direction, the direction of the magnetic field depends on the direction of the current flowing in the conductor. The direction of the generated magnetic field can be indicated by the direction of the deflection of the compass needle placed around the conductor. Sama juga dengan yang sebelum ni, kalau nak tahu dia punya arah dia, you boleh letak kompas. The straight wire conductor, the direction of the magnetic field is determined using the right hand grip rules. Ataupun salah satu cara dia adalah menggunakan petua genggaman tangan kanan. It's a right hand grip rules. Okay. So if you have this one root bar and then you insert the current through this bar, okay. So the current this is the bar and the current flow ke atas, okay, this is the current, Okay, this is indicate the current, your current. Okay, and this one is indicate your arah magnetic field. Okay, the direction of the magnetic field. So if you have a current through this, okay, it means that this is the direction of the magnetic field is counterclockwise. Okay, okay, this is your current. This is indicate your current. Ibu jari awak ni, okay, indicates current pergi ke atas, and this is the direction of the magnetic field. The magnetic field formed by straight wire are concentric circle around the wire as shown in the figure. Inilah, okay. Saya kata tadi kalau wire awak ni ataupun you punya root ni ada arus, okay, so akan ada magnetic field around this wire. Takes note that when the direction of the current is inverse, the direction of the magnetic field is also inverse. Yalah. If your current direction is upwards, so your magnetic field um, is anti-clockwise. Okay, the direction of your magnetic field is anti-clockwise. If your current is up down, okay, if your current is down, okay, so your direction of the magnetic field is clockwise. Okay, this is how you find you determine the direction of the magnetic field by using the right hand grip rule. Okay. Okay, the direction of the magnetic field line can be determined by the Maxwell's screw rules or the right hand grip rules. Okay, right hand grip rules or Maxwell screw. Jadi saya tunjuk Maxwell screw tu. Okay, sometimes the magnetic field pattern may be given in the plan view. Okay, this is the plan view, means that you look from the plan side or you look daripada atas. Okay, it's a plan view. Okay, in plan view, a dot in the wire shows the current coming out. Okay, kalau dot ni means that current you coming out. Okay, and this X, it shows that the current is moving into current dia masuk. Yang ni means current dia masuk, yang ni means current dia keluar. Okay, so if your current keluar kan, so your direction is anti-clockwise. Okay, this is your current moving into, this is your current coming out. Okay, this is the plan view. Okay, how to define the direction of magnetic field? Ada you can use your right hand grip rules macam saya tunjuk tadi. Okay, or the other one Maxwell's screw rules. Okay, the Maxwell's screw rules ni, the direction of the rotation give you the direction of the magnetic field. Okay, your screw, kalau kita masukkan screw, kita nak ketatkan screw kita, maksudnya this is the direction of your current, this is the direction of your current. Katakan you punya arus masuk. Okay, so kalau you nak ketatkan screw, nak masukkan screw ni ke dalam, okay, so you kena pusing dia clockwise. Okay, so this means that this is the direction of the magnetic field, and screw masuk ke dalam tu is the direction of the current. You boleh guna dua-dua. You can use this two ways how to find the direction of the magnetic field. Tapi for me, this one lagi senang faham lah. Okay, right hand grip rules ni. Okay, this is how to use the right hand grip rules, and this is the Maxwell screw rules. Okay. Strength of the magnetic field. The strength of the magnetic field formed by a current carrying conductor depends on the magnitude of the current. a stronger current will produce a stronger magnetic field around the wire. Okay. So kalau you punya wire, kalau you punya current dia besar, means that uh, your magnetic field ni lagi banyak lah. Okay. Lagi banyak dan lagi stronger. Okay. The strength of the field decrease out as you move further out. Okay. This you must be careful that when you were asked to draw the magnetic field in your exam, the distance of the field line must increase as the further out from the wire. So you can see here is how to draw the magnetic field. Okay, so lagi jauh daripada arus ni ataupun daripada dia punya wire ni, dia punya gap dia lagi jauh lah. Okay, means that this is a stronger field and this is a weaker field. Okay. Okay, magnetic effect of a current carrying conductor coil. Okay. Okay, this is coil. Okay, means that this is not only the one bar. Okay. Okay. This is the coil. Okay, you have a wire here, and you also have a wire here. Okay, but it's the same wire. Okay. So the field pattern produced by a current flowing in the circular coil. Okay, the direction of the field can be determined by the right hand grip rules. Grip the wire at the one side of the coil with your right hand with thumb pointing along the direction of the current. Your other fingers will be pointing in the direction of the field. Sekejap. The field pattern, okay. So actually, this is same as the previous one, sama je dengan yang previous tadi. Kalau ada satu root pun, but this one, coil ni is a circular coil. Okay, so how to find the how to find the direction of the of the magnetic field ni sama je dengan yang you guna before this. This is by using a right hand grip rules. Okay, so for this there is current through this. Okay, so yang ni arah arus dia keluar. Okay, this one is arah arus dia masuk. Okay, so this for this, okay, okay, ni arah arus keluar and then this is arah arus masuk. This is arah arus keluar, so the magnetic field direction is anti-clockwise, and this is arah arus masuk, and the direction is clockwise. Sama je sebenarnya. Okay. Okay, this is the curve and coil conducting wire, and how to find the direction? Just use your right hand grip rules. Okay. This is arus masuk and this is arus keluar. This is arus masuk and this arus keluar. This is macam mana? Okay. Dia punya direction of the magnetic field. Okay. Factor affecting the strength. There are two ways to increase the strength of the magnetic field. The first one is to increase the current, and the second one is increase the number of turn of the coil. Okay. So kalau lagi besar dia punya arus ni, lagi kuatlah magnetic field, ataupun lagi banyak turn ni dia punya bilangan coil tu, lagi banyak bilangan turn dia, so lagi tinggi dia punya magnetic field. Okay, and then this is the solenoid. Solenoid is a long coil made up of the number of the turns of wire. Okay, a solenoid is a long piece of wire which is wound in the shape of the coil. When the electric current passes through the coil, it creates a relative uniform magnetic field inside the coil. The solenoid can create a magnetic field from an electric current, and this magnetic field can be used to generate a linear motion with the help of the metal coil. This simple device can be used as an electromagnet, as an inductor, or as a miniature wireless receiving antenna in a circuit. Actually, inductor in the circuit tu adalah solenoid. Okay, yang kita um, belajar in the previous topic, we have a inductor. Actually, the inductor is a solenoid. Okay, okay, this is the solenoid. Okay, we have a several number of coil. Okay, okay. The magnetic field of the solenoid resembles that of the long bar magnet, and it has a north pole at one end and south pole at another. Okay, so here is a current. Magnetic field generated by the soil is the field pattern is resembled as a long bar magnet. Actually, um, this magnetic field for the solenoid is same as a magnetic bar. Okay, apa yang nak cakap kat sini adalah sebenarnya um, magnetic field dekat solenoid ni dia sebenarnya sama je dengan magnetic field dekat satu bar magnet. Okay, dia umpama dia ada kutub utara dengan kutub selatan. Okay, how to determine the pole of the magnetic field? Okay, you can determine the pole by using the right hand grip rules. Okay, right hand grip rules. Imagine your right hand gripping of the coil of the solenoid such that your finger point at the same way as the current. Okay, your thumb then point in the direction of the field. Okay, this is the solenoid. This is the direction of the current. So your ibu jari ni menunjukkan this is the north pole of your solenoid. Okay, this is another method. Strength of the magnetic field, you can increase your current, you can increase the number of turns, you can using a soft iron core within your solenoid. Okay. In solenoid tu dia ada one core metal or iron. So the types of the iron tu akan menentukan you punya strength of the magnetic field. Okay. Okay, and then where the electromagnetic application, where we apply this electromagnetic. Okay, this is the first. Okay, in the electric bell. Okay, so this is the application. So ni ada dua-dua ni, saya bagi in Malay, saya bagi in English juga. Okay, so you can go through, you can baca macam mana dia boleh bunyi, elektrik ni macam mana dia boleh berfungsi. Okay, and then we have a electromagnetic relay. Relay is one of the electronic component we use as a automatic switch. Okay, we use a relay as an automatic switch. Means that dia boleh on off your circuit automatically. Okay, so how the relay function? You can read this. Okay, so saya tak terangkan nanti you baca. Okay, sebenarnya dia punya application dia macam mana dia function sama je. Okay, and then this is the circuit breaker. Okay, how its function, and then this is the telephone earpiece. Okay, saya tak terangkan nanti you baca je. And force on the current carrying conductor in the magnetic field. Okay, when a current carrying conductor is placed in the magnetic field, the interaction between the two magnetic fields will produce a force on the conductor. It's called a catapult force. The direction of the force can be determined by a Fleming left hand rules. Okay, kan di kanan kan, di kiri. Okay, so um, the forefinger, middle finger, and the thumb are the perpendicular to each other. The forefinger point along the direction of the magnetic field, middle finger point at the current direction, and the thumb points along is the force. The strength of the force can be increased by the increase the current and by using a stronger magnet. Okay. Why is the catapult field or the Madden elastic kita panggil dia? Okay, if you have this two magnet, okay, if you have these two magnet, you have a magnetic field across this magnet. Okay, you have a magnetic field across this magnet. Okay, and then you have another wire that carrying current. Okay, so you know that when you have a conductor or you have a wire that carrying a current, so there are magnetic field around that wire. Okay, so sekarang ni antara magnet ni um, ada magnetic field dengan you punya conductor ataupun you punya wire pun ada conductor ada magnetic field. Okay, so if you interact of these two magnetic field, okay, so awak dekatkan awak punya conductor, okay, yang ada magnetic field dengan awak dekatkan dengan magnetic field yang lain ni, okay, so dia akan hasil one force. Okay, dia akan hasilkan satu daya. Okay, di mana kita panggil medan elastik. Okay, so akan terhasil force antara benda ni. So sekarang ni you punya conductor ni, if you lalukan dia uh, dekat magnetic field ni, okay, so dia akan terhasilnya satu daya. So daya ni selalunya dia akan tolak you punya conductor ni. Okay, you punya wire ni dia akan bergerak. Sama ada dia push to up or dia akan push to down. Okay. What happened to a current carrying conductor in the magnetic field? The catapult field or medan elastic, dia akan terhasilnya medan elastic. An electric current carrying conductor produce an electric field around it. Okay. So you know that this is the wire. Kalau wire ni dia ada current, so dekat luar dia akan ada magnetic field. Okay. If this wire have a current flow through this, so you know that this wire, around this wire have a electric field. Okay, so if an electric current carrying conductor is in another magnetic field, a force will act on that conductor. Okay. So yang ni ada dia punya magnetic field, this one pun ada dia punya magnetic field. So kalau you lalukan this magnetic field dengan this magnetic field, so akan terhasilnya satu force. Okay, so the force ni, the wire move outward. So the force ni akan tolak this wire pergi ke atas. Okay, force tu kan daya. Okay, so the direction of the force can be determined by using a Fleming left hand rules. This one. Okay, so this Fleming left hand rules, hukum tangan kiri Fleming. Okay, this is indicate the current. Okay, this is indicate the you punya current masuk ke, current you keluar ke, arah current. Okay, this is the current direction. Okay, this is the magnetic field. This is your magnetic field from north to pole, north to south. Okay, this is your magnetic field daripada utara pergi ke selatan, and this is the force. Okay, this is the force, arah force. Okay, the force direction. Okay, So here, so the wire, so you know that this wire, okay, this is the current, okay, flow through this. So this is the current, okay, and then this is utara selatan. This is utara selatan. You punya magnet bar ni kan, utara selatan. Or you punya magnetic field ni dari arah utara pergi ke selatan. And this is your current, okay, and this is the force. Okay, so arah force dia akan ke atas. Sebab tu arah force ni pergi ke atas. Nampak tak ni? Okay. This is a current. This is the current. Okay. The positive, negative. Arah current. Nampak jari awak yang ni? This is arah current. This is the current direction. Show your current direction. And this is the magnetic field. The magnetic field is from north to south. This is north. This is north. To here. Okay. To kanan. And this is the force. Okay. So, daya ni dia akan tolak awak punya wire ni pergi ke atas. Okay. Cara tentukan tu. Okay. If your current through here, okay. If your current through here, katakan yang awak punya current masuk dalam, bukannya keluar ke sini, tapi masuk ke dalam. Okay. So your force akan pergi ke bawah. Okay. Cara tunjuk dia lah. The force between the two current and carrying conductor. Okay, when two current carrying conductor are placed close to each other, a force will be generated between them. If the current in both conductor flow in the same direction, they will attract each other, whereas the current of opposite direction, they will repel each other. This force is due to the interact between the magnetic field of the two conductors. Okay. Okay, force on the current carrying conductor in the magnetic field. Okay, ni yang saya terangkan tadi lah. Okay, so if you have a like before, macam sebelum ni, there are just one wire kan. Okay, this one have a two wires. Okay, means that you have a current flow in and you have a current flow out. Okay, so here, but you can use the same method to know your direction of the force by using the hukum tangan kiri Fleming awak ni. Okay, so you know that this is the current. Okay, this is the current. Okay, okay, this is the current. Current in. Okay, this is current in. Nampak tangan sini. Okay, this is current in. Okay, just look at this side. Okay, this is current in. So the current in. Okay, so this is north and this is south. This is south. Okay, this is the force. Okay, so the force is ke atas lah. Okay, okay. So here the current is out. Okay, so current keluar. But I say this is not, this is not right. Okay, macam ni. Okay, so your force is down. Macam susah sikit lah, tapi you kena make sure you punya tangan ni betul lah, jari awak ni tunjuk betul. Okay, so ni arus masuk di utara, selatan, and force is up. Okay, so arus keluar macam ni kan, tapi this is not, this is not ni utara, ni selatan, tak boleh. Awak nak sini selatan, sini this is utara, this is selatan, but in your slide, this is selatan, this is utara, betul? So you can pusing dia macam tu lah. Nampak tak? Force dia ke bawah, this is utara, and then this is selatan, and the current is flowing up. Okay, this is how you to know the force direction in a circuit lah. Okay. Okay, the example of electric equipment operation is based on the tuning effects on the direct current motor you guna benda ni dalam motor and the moving coil meter. Okay. Okay, this is what is the principle of the direction current motor movement. Okay. This is the motor, how your motor works. Okay. Macam mana motor tu bekerja. Okay. Dia guna prinsip ni. When the current flows through the coil, okay. Okay, sekarang ni you have a coil or you have a rod ni lah. Okay. So when you have a current through this, okay, force are generated on the AB and CD side. This is the AB. Oh, tengok sini. AB, this one is AB, this one is CD. Okay. Dalam ni tak ni pula. Okay. So, this is AB side. Okay. When the current flow through this side and this side. Okay. So, yang ni arus masuk tu. Okay. This is current flow through this. Arus masuk. Okay. This is not and this is not. So, this is the force. So, your force akan ke atas. Okay. And then yang ni arus kedua, your force akan ke bawah. So, the direction of this force can be determined by using the Fleming left hand rules. The effect of these two forces will produce a rotational force that causes the coil to rotate clockwise. Okay, so disebabkan inilah akan membuatkan benda ni berpusing. Okay, sebab itulah awak punya motor pusing. Dia menggunakan prinsip ni, magnetic. Okay, ini pun sama je lah sebenarnya. Okay. What is electromagnetic induction? Okay. Electromagnetic induction is a process in which a conductor is put in a particular position and magnetic field keeps varying or magnetic field is stationary and the conductor is moving. This produces an induction current flowing across the electric conductor. Okay. Induction. The word induction is induction means teraruh. Okay, in Malay is teraruh. Okay, so if you have a satu magnet and you have a one wire, okay, so sama ada, so you know that magnet tu sendiri dia ada magnetic field. Okay, wire tu dia tak ada magnetic field. Kalau you kalau you bagi dia apa nama? Current, baru dia terhasil magnetic field dekat luar ni. Kalau dia tak ada current, dia tak adalah magnetic field, betul? Tapi kalau magnetic bar, okay, dia memang ada magnetic field dekat luar ni. Okay, so in this case, electromagnetic induction, it can produce when you move this bar into this wire, or you move this wire into this bar. Okay, so sama ada awak gerakkan ni, this bar ni melalui wire, ataupun awak gerakkan wire ni dalam bar ni, okay, will produce the electromagnetic induction. Akan terhasilnya aruhan elektromagnet. So, if terhasilnya aruhan elektromagnet, means that akan ada arus mengalir. Okay, so there are there are current will across this wire. So you boleh nampak dekat you punya meter ni bergerak. Okay, because there are electromagnetic induction. Ada aruhan elektromagnet yang terhasil. The direction of the induced current and the magnitude of the induced EMF due to the cutting of the magnetic flux can be determined from the Lenz's law or Faraday law. So, untuk induction ni, there are two law yang berkaitan dengan dia, the Lenz's law and the Faraday law. Okay. Faraday law ni dia cakap, why is the Faraday law state that the magnitude of the induced EMF is determined from the Faraday's law. Faraday's law state that the magnitude of the induced EMF is the electromagnetic force. Okay, is a directional proportional to the rate of change of magnetic flux through a coil, or alternatively the rate of magnetic flux being cut. Okay, so Faraday law ni dia cakap the value of the induced EMF, the value of the daya elektromagnetik yang teraruh tu akan bergantung kepada berapa banyak magnetic flux yang terkat apa kan terpotong. Okay, so means that Faraday law ni dia cakap berapa banyak magnetic flux yang terpotong ni akan menunjukkan dia berkadar terus dengan berapa banyak electromagnetic induction awak yang terhasil. Itu maksud dia. Okay. And Lenz's law, when the magnetic is moved into and out of the coil, the induced current that flows through the coil can be determined from Lenz's law. Lenz's law states that the induced current always flows in the direction that opposes the change in the magnetic flux. Yang ni dia jadi dia nyatakan current yang flows into the direction that opposes with the change of the magnetic flux. Yang ni dia more to the current lah. Okay. Lenz's law obey the principle of the conservation of energy. Work is done to move the magnets against the repulsive force. This work done by converting the electric energy which manifest in the induced current. So Lenz's law ni dia menunjukkan bahawa electromagnetic force yang teraruh tu akan menghasilkan arus. Okay, yang kita panggil induced current. Okay. Fleming right hand rules. Fleming right hand rules pula is used to determine the direction of the induced current that flow from the wire when there are a relative motion with respect to the magnetic field. Okay. Okay, the Fleming right hand rules kita tentukan for the induced current. Okay. When the magnet bar is moved into the solenoid, the galvanometer needle is deflect to one side. Okay. Okay, this one. Kalau you move this bar into this, so dia akan ada induced current. So your galvanometer ni akan bergerak. Okay. Tapi when you letak this bar inside the solenoid, means that there are no movement. Okay. The galvanometer needles return to its original position, means that there are no induced current. Okay. But when the bar magnet is moved out, tapi bila you keluarkan balik, okay, means ada the magnetic field ada there cutting of the magnetic field. Okay. So the galvanometer needle is a defect to the other sides, means that dia akan bergerak lah, means that ada arus yang bahasa Melayu ni. Okay. Electromagnetic induction types of current. You have a direct current, okay, and you have a alternating current. Ini ada arus ulang alik dan ada arus terus. So induction current ni dia boleh menghasilkan dua-dua arus ni, dia boleh hasilkan arus terus, dia boleh hasilkan arus ulang alik. So it used for the DC generator. Okay, this is the use for the DC generator. Macam mana dia boleh hasilkan arus terus, okay, daripada sini. Okay, this is the simple DC generator. Okay, and it can produce it used in a AC generator. AC generator ni maksudnya penjana arus ulang alik. Okay, boleh digunakan, konsep ini digunakan dekat penjana. Okay, penjana ulang alik dengan penjana arus terus. This is how it works. Okay, boleh baca lah. Okay, what is the transformer? Okay, this one nanti you baca dia punya konsep tu sama lah actually. Okay, dia ada dua. Actually dia ada motor, dia ada generator. For motor, konsep dengan motor ni sama. Okay, this is generator, and this is motor. Okay, for motor, you masukkan arus, you supply arus in the motor, and then you punya road ni akan bergerak. Okay, beza dia. Motor, you supply arus and then dia gerak. Maksudnya, is a convert from the electrical to the mechanical or to the kinetic. Okay, mana bila awak produce untuk motor, awak masukkan arus baru dia gerak, betul? But for generator, okay, dia menggunakan electromagnetic induction. Okay, di mana okay, unit tu dia gerak benda ni dulu baru dia produce arus. Nampak tak beza dia? Okay, dia gerak benda ni dulu baru dia produce arus. You need to move the coil first, and then it will produce the current lah. Okay, it is different with the motor. Motor and a generator is a different. When a motor, you need to convert from the electric into kinetic, and for the generator, from the kinetic convert to the electric. Nampak tak? Okay, but how it works tu benda yang sama. Okay. Okay, transformer. What is this transformer? Okay. Okay, this is the transformer. Transformer is a device that is used to raise or lower down the potential difference of an alternating current. Okay. This transformer is used to convert your current or your voltage, okay, either to step up or step down, either to increase or decrease. Okay, so you guna transformer ni untuk you naikkan you punya voltage ataupun untuk turunkan voltage you, ataupun untuk naikkan arus ataupun turunkan arus. Okay, this is the structure of the transformer. You have a three parts: a primary circuit, the core, and the secondary circuit. Okay, this is the core. Okay, transformer core. Okay, macam satu bahan logam lah. Macam it's like a magnet. Core. Okay, so you have a coil. Okay, we name it as a primary, and we name it as a secondary. So if you look at this, we have so many turn here, there's so many coil here, means that the value for the voltage or the current here is high. Okay, so there are a few coil here, okay, less than here. Okay, so it means that the voltage and the current here is low, okay, compared to this. Okay, so this is the primary circuit. The primary circuit is the circuit that connected to the input energy source. Yang primary ni tadi, we connect to the input. The current, potential difference and coil in the primary are called the primary current, primary potential difference, and the primary coil respectively. Okay, so dekat sini kita akan panggil dia, we call it as a primary. Okay, so if you have a voltage or current here, we call it as the primary voltage and the primary current. Okay, the coil is the ferromagnetic metal wound by the primary and the secondary coil. The function of the coil is to transfer the changing magnetic flux from the primary coil to the secondary coil. Okay, so this is the magnetic. Actually, this is the magnet. Okay, so it will transfer this into this. Okay, so it will transfer, if you have a voltage or current here, it will transfer the voltage and current to this from the primary to the secondary. Okay, and the secondary circuit is circuit that connected to the output. Okay, so this is connected to the output, and this is connected to the input. Okay, we call it as the secondary. Working principle of the transformer consists of the primary and secondary. When the alternating current flows in the primary, a changing magnetic flux is generated around the primary coil. The changing magnetic flux is transferred to the secondary through the iron coil. The changing magnetic flux is cut by the secondary coil, hence induce the electromagnetic force in the secondary coil. The magnitude of the output voltage can be controlled by the ratio of the number of the primary coil and the secondary coil. Okay. This is types of current in the transformer. Okay. It must be alternating current. Transformer cannot be a direct current. Dia mesti alternating current. Dia mesti arus ulang-alik je yang boleh lalu transformer ni. Arus terus tak boleh. Okay. The induced current in secondary is also the alternating current, and the frequency of the alternating current in secondary coil is same as the frequency in the primary current. Okay. It can convert it into the direct current by using a pair of diode. Okay, dalam transformer tu sendiri tak boleh you convert direct current. Kalau you nak convert, you need to connect it into diode. Okay, maksudnya you kena ada lintar lain lah. This is the symbol for the transformer. Okay, you have a coil here and we have a coil here. We call if you connect it into the input, so we call it as premium, and we call it if we connect this into the output, and we call it as the secondary. We have two types of transformer, is a step up transformer and a step down transformer. Okay. So step up ni kita panggil dia, bahasa Melayu dia adalah injak naik. Transformer injak naik. Okay. Okay. Transformer bahasa Melayu, pengubah. Okay. Pengubah injak naik. Okay. Means that this step up transformer, you need to convert from the lower voltage or the lower current into the higher one. Okay. For example, if you have a voltage input is a 20 volt, so you need to use a step up transformer to convert it into the 100 volt. Okay. So penjana injak naik or step up transformer ni, kita gunakan dia untuk menaikkan voltan ataupun menaikkan arus kita. Okay. And a step down is used to step to penjana injak turun. Means that if you have a huge value of voltage or current, you want to reduce it, you use it as step down transformer. For example, if you have a 100 volt, you want to convert it into the 5 volt, so you use a step down transformer. Okay, so step down transformer ni digunakan untuk menurunkan arus ataupun menurunkan kita punya nilai voltage. Okay, here where we use this transformer, actually this is the power plant. Okay, this is the power plant. How you get the electric or how you get a voltage dekat you punya house. Okay. Okay. So this is the power plant. Okay. It supply a 2 kilovolt. Okay. There are step up transformer here to increase the voltage here. So this step up transformer will increase this voltage into 400 kilovolt. Okay. So this is the transmission line. Okay. If you can see this is high voltage transmission line. Kalau you tengok pun this transmission line, dia tak ada. Transmission line ni is located far away from your house. Okay. Tak ada transmission line ni dekat sebelah rumah awak, betul? Kalau kita nak tengok, selalunya kita akan nampak dekat bukit, dekat gunung-gunung, dekat tengah padang. Okay. They are located far from your house lah, sebab is have a very high value of voltage. It's a 400 kilovolt here. Okay, so this is apa nama? tiang elektrik dekat rumah awak. Okay, betul. Okay, dekat sebelah-sebelah rumah awak ni ada tiang elektrik ni. Okay, so it gets the value for the voltage from this transmission line, but before we transmit it into this apa nama bahasa Inggeris dia orang panggil yang di tiang elektrik ni, okay, you kena lalu step down transformer, okay, dekat substation. Okay, so this 400 kilovolt, okay, we'll need to convert it into 13 kilovolt. Okay, sebelum dia sampai kat rumah awak ni, dia kena turunkan your voltage by using a step down transformer. Okay, nampak tak? Yang ni dia step up, this one is step down. Okay, and then you get a 13 kilovolt. Okay, tapi masuk dalam meter awak ni ada lagi step down transformer. We have another step down transformer before we supply it into your house. We just get a 240 volt. Okay, this is the macam mana lah you dapat elektrik sebenarnya. Power plant ni actually sebenarnya power plant ni dekat empangan, kita punya empangan. Okay, dekat Malaysia kita guna sistem hidrolik. Okay, sistem hidroelektrik. Sistem hidroelektrik. So we get the voltage from the hydroelectric. Okay, dam. Okay, it's from a dam. So macam mana penjana ni function actually yang saya terangkan tadi. Macam mana dia function? Ni, this one. How you get the value for the voltage here? It use this. Okay, it use this. Okay, so you boleh tengok dia punya, you can awak boleh Google ataupun awak boleh tengok dekat YouTube. Okay, how you can get the voltage here. Okay, macam mana penjana itu berfungsi. Okay, you boleh tengok dekat YouTube. Okay. Okay, this is the simple calculation for the transformer. Okay, this is a voltage in primary, voltage in secondary. This is number of turn of number of the coil or number of the turn in your transformer. This is on primary, this is secondary, and this is the current for secondary and the current for primary. Okay, this is an example. What the example step up transformer. Okay, 120 volts transmit to the 100 kilovolts, means that this is the P and this is the Vs. Okay, the primary has a 50 loop, so this is NP and draws a current 100 ampere, so this is IP. Okay, so dekat sini dia nak cari what is the NS. Okay, you find the NS, you have the IP, what is the IS. Okay, you can use this is the equation. Okay, this is the equation. Muka dia saya tak tunjuk sangat lah sebab tak apalah, tak perlu tahu. Sebenarnya tu saya baru letak dia tadi. Tak ada pun calculation, Dr. Nazirah tak tunjuk pun, instead dia tak tanya kan. Tapi saya dah tengok dia punya final exam question, tak ada soalan pasal topik ni. Okay, kalau ada nanti saya bagi tahu. So far saya tengok tak ada lah. Okay, this is factor that affect the efficiency of the transformer. Okay, apa nak bagi punya transformer tu lebih efisien ataupun benda yang boleh menyebabkan transformer awak kurang berkesan. Okay, the heating effect, okay, of the current in the coil. This is one of the factors, and this is the method how to increase the efficiency. Okay, and then heating effect of induced current. Okay, this is what's going on. Okay, and this is how to increase the efficiency of your transformer. Okay, and the magnetization of the iron core, your iron core itself, um, maksudnya the magnetic bar in the transformer. So how it can uh, produce the energy loss in your transformer, and how to increase the efficiency. Okay, maybe you can use the other type of iron core. Okay, and then the next one is the flux leakage. Okay, some of the induced flux, magnetic flux from the primary coil is not transmit to the secondary. Okay, so the method to increase the efficiency is uh, intertwined tightly with the primary coil. Okay, okay, that's all. Okay, ada berapa soalan tak nak tanya? Oh, satu lah. Okay, so actually this topic you can awak boleh baca, okay, you boleh faham, and then you can read it by yourself lah. Okay, so um, um, nasib baik lah kita punya topik yang calculation semua kita dah habiskan before lockdown, so tak ada masalah sangat. So today just a theory, okay, just a theory, tak ada sangat calculation, and I think you can understand if you read it by yourself. Okay, okay, ada beberapa soalan nak tanya. So today is our last class, so there are no lecture for next week and the following week. So today is our last class. So thank you for everything. So I hope apa yang saya ajar you boleh faham. So kalau you cannot understand what I teach you, you can ask me. Okay. You can also text me personally if you want. So sebab tak ada soalan before jangan awak tiba-tiba cik saya tak faham minggu kedua punya lecture. Yang tu memang nak kena lah saya. Okay. So so saya rasa I already buat yang terbaik nak bagi awak faham, dan saya harap awak faham. Okay, so if you can answer all the question in your test tanpa ada sebarang masalah, I think you understand what I teach you. Okay, okay, ada berapa soalan lagi? You have any question? Tak ada. Okay, so kalau tak ada apa-apa, that's all from me. Oh, before that, buka jap you punya kamera, saya nak ambil attendance. Okay, I will send you the apa nama, Google form for the attendance. For the last week, we replace the last week class with the test actually, and we have three attendance need to fill up. Okay, so I will send the three attendance for the week 10, week 11 and week 12. Okay, nanti saya masukkan tarikh siap-siap lah supaya you tak confuse. Okay. Okay. That's all from me. Thank you. Kalau ada apa-apa masalah, kalau saya ajar awak tak faham ke apa benda ke, saya minta maaf. Okay. So saya halalkan semua apa yang saya ajar dekat awak. Okay. Dan saya harap apa yang saya ajar ni bagi awak satu ilmu yang baru. Okay. Saya tahu sebelum ni semua tak tahu pun pasal elektrik. Okay. But today you know it well, I think. Okay. So thank you everybody. Jumpa lagi insyaAllah. Kalau panjang umur, murah rezeki. Thank you.
Thank you, Miss.
Okay.
Thank you,
Okay,
Miss.
Miss, thank you so much. Have a good
Thank
day.
you, Miss. Thank you so much.
Thank you, Miss.
Thank you, Miss.
Okay.